Okay, this is Durwood King with Sampson Community College, and this is September 17, 2020, and this is the class ELC 111, Intro to Electricity, and we are working on series circuits worksheet today, helping folks finish the calculations on series circuits. We're going to do that via the webcam, and then after that, we'll move into advanced Ohm's law formulas, and okay, so we're going to start out. I'm going to be helping the students again via webcam to complete this worksheet before we move on further. So I'm going to do a screen share. And by the way, if anyone happens to be watching the video that's not connected with our college, my name is Durwood King, and I would be glad to answer any questions about you being able to enroll in our programs. We have a variety of offerings. We have certificates that you can get in about a year, the electrical certificate, mechanical certificates. We have a degree, industrial systems degree that has electrical, mechanical, hydraulic, pneumatic, machine shop, welding, refrigeration. You get all that bundled into one degree called industrial systems that'll help you to be a multi-craft maintenance technician, which is what most plants want. Then we also have a new electrical degree that is strictly electrical, that is major on that. And it includes about 50% industrial electrical classes and roughly 50% commercial, residential, and National Electric Code type classes that are involved in that. So it's a blend of residential, commercial, and industrial and solar fields in the new electrical degree. So if you want to narrow it in on electrical, actually it's not narrow by no means, but it's electrical, but it's wide range in electrical. Then let me know and I'll be glad to get you some information on it. And so we got some more students joining in. That's good. Hey, Rob, how you doing, buddy?
Good. You?
Hanging in there, man. Good. Nicholas, how you doing, buddy?
Good.
Great. I'll go ahead and mention something, and I'll try to remember to mention it again when more people get in. Is yesterday morning I took my mother to get a colonoscopy here in town, and they found a large tumor in her colon, and it's almost obstructed in there. She's got to have part of that colon taken out real soon, real quick. So I'm taking her to Rex Hospital in Raleigh tomorrow to talk to a doctor. And depending on how soon they do it, I'm hoping they're going to do it real soon, because the opening in her colon is down very small now, but we're supposed to be large. So it's got to happen quick. So what I'm getting at is that, hold on. I know that's not for me. That's Pennsylvania. I don't know anybody up there. But here's what I'm looking at. Depending on what day they do the surgery, you know, they may do it this weekend. I don't know. But if there's a slight chance that if they do it early next week, that I may not be able to join with you Tuesday here, that we may end up being online again. But I'll let you know tomorrow afternoon what it looks like for next week. So I'll let you know a couple of days in advance what my plan is. It'll you know, if it's not, if I happen to have to be up there, say Tuesday, I'll have a plan for something for you to do. You know, either strictly in Moodle or me do something with you in Zoom. It will probably just simply be a Moodle assignment that I would have ready for you. And the way things are looking right now is if that's the case, I would give you an assignment in chapter 4 in parallel circuits for you to go ahead and read and work on a worksheet. So kind of be checking your emails. And I've also put together a text group with phone numbers. I've got everybody's updated phone number. And just as a backup, I'll also do a text message to give you, because some folks still, even after they've been here at school a year or two, are still not really checking emails like they're supposed to. So So I have to resort to texting sometimes when we have something, an emergency. This is an emergency here. So, but I'll make sure that you got something to work on that you can keep moving forward. You're not going to lose any time. I guarantee you that. So, and I'm still available by phone. Even if I miss Tuesday, I'm available by phone to help you with questions and all. So, so anyhow, we'll move on forward. So the plan right now, we are recording. The plan for today is there are 5 people that have not submitted worksheet 3 for series circuits. I'm going to help those folks right now finish that worksheet via the webcam so that I make sure everybody can get it done today. Then we're going to go right into today. We're going to go into advanced Ohm's law formulas using the pie chart. The pie chart has a lot of formulas that we haven't used. We're going to use those today in the session too. The ones that have the I squared times R, E squared over R, and the power over resistance, and then the square root and so forth. And then you have power times resistance. The square root of that equals voltage. So I'm going to be giving you some variables just so you'll know. Those of you that have done worksheet 3, I just put this in Moodle right here. Y'all see that chart?
Yeah.
And I'll say, Nicholas, you've turned in the worksheet 3. You've done it. So your next step, while I'm helping a couple of people that need help in worksheet 3, if you want to kind of while you're listening, you can kind of click on this. It is in week 5 section for week 5 in Moodle for here. You can go ahead and click it and be looking at it. And basically, there'll be 2 variables you'll be given, and then you have to answer 2 unknowns.
Okay.
And it's going to involve, I'll just give you an example. That way you'll know, and we're not holding you up, okay? Let's say, for instance, row number 4 here. Row number 4 is giving you current and it's giving you wattage. Now, it's asking you for volts and it's asking for ohms, right?
Yeah.
Now let's just say, for instance, let's do a new formula that way, and this can get you started here. Let's say, for instance, on row 4, that you wanted to calculate the resistance, but you wanted to do it with one formula directly. Instead of having to do some other formula and end up maybe doing 2 formulas to be able to get to that, there's a direct way to do it with the pie chart. So we know we have wattage and we have amps, right?
Yep.
And let's see if we can find resistance straight from that. So let's go to the pie chart. And look at here. For R, for resistance, do y'all see that pretty good?
Yes.
So for R, there are three formulas you can use to calculate R. So resistance can be found if you have the voltage in the amps by dividing, or resistance can also be found if you have voltage and you have power in watts. So you would take the voltage and square it. Now, who knows what squaring means? Yeah. So E squared would be whatever that voltage is. If it was 120 volts, it would be 120 times 120, not 120 times 2, but it's actually 120 times 120. If your calculator doesn't have a square button on it, but most of them are going to have a square button. Okay. I've seen a few cheaper ones that didn't, but if you didn't have it on yours, it would be the voltage times the voltage, not the voltage times 2. So in this case, you can take the voltage squared divided by the wattage. And see, that's a formula we haven't looked at, but you need to be able to use every one of them in that pie chart. And that's what this assignment is about. is so that you can get familiar and be aware of all the formulas that you can use in that pie chart, that is all very useful. And there's a reason for every one of them that's in there. There's a reason for every one of them being in there. I don't know, I'll mention this again. Y'all have to help me remember to give you one of my business cards that has these on the back of it. So my college business card here, if you flip it around, and there's some of them laying on the table down there in the shop. I need to put another stack out there. That way you can get, that might be the easiest thing for me to lay a stack of them out there again. There's a few out there. I need to put more. But that whole pie chart is there with the triangles. And it's very easy. Stick it in your wallet, your pocketbook, you know, and you'll always have it. So it's just a nice thing. I saw a company, a refrigeration company, giving out cards, General Refrigeration, and they had it on the back of theirs. And I said, man, that's the coolest thing. And I've got to have it on mine. So I had, when they printed our cards, I had that done. So it's a very, very nice thing to have. And I'll tell you, when you think, well, we say, well, why in the world would I want to have it in my wallet? Let me tell you this. You go on a job interview, there are some jobs that give you an electrical test as part of the interview. And it could involve Ohm's law. I mean, I've seen electrical tests. I took them on job interviews before. I mean, for real. So some companies would not. They just go strictly off of your resume and your transcript. Some of them, they want to see what you can do right there on the fly. You know, not what you've done, but what can you do right now, right off the top of your head, what can you do? So that's something that does happen with some jobs. Okay, so you get the idea. Yeah, so yeah. In row number 4, you would be taking, well, actually on row 4, it was amps and watts, not volts, but amps and watts. So let's take a look at that, amps and watts. They got a formula for that too. Look, R can be found by taking the watts divided by the square of the amps. You see that? So you have wattage, P is watts, power and wattage, and I is current. So you can take the wattage divided by the square of the amps. So you need to square the amps first, you know, and then say watts divided by amps squared. So those two can give you the resistance directly. And you say, well, you know, well, maybe I just kind of want to stick with the triangle, with the 2 triangles, and do an intermediate formula and then do another one to get the answer. Well, here's what can happen. When you do that, if you round too short, if you round your numbers too short, there can be a little bit of a drift in the answers, and it may not be right on point, you know. Hold on, let me check this in case it's a student. Hello? Hey, Mr. King, I'm sorry. I'm trying to get back in, but everything just went down at my house. That's okay. You can, I can leave the phone on like that, and if you want to talk like that, just like you are right now, be fine. Okay, let's do that. That's cool. Let's see if I can turn the volume up. Yeah, I turned the volume up. Do you see me or not? You completely lost the signal? Everything just went down. Okay. So are you in a mobile home? But the house that you're in, it doesn't have metal walls? Like metal siding or anything? Got vinyl siding, okay. I didn't know. I know there's some places that you can be in, if they got metal walls, it'll block the signal. It doesn't have a good signal. Yeah, it's weather related. Weather, I understand. Well, we can still make do like this, and I'm gonna show you how we can do it. I'm gonna show you we can work with what we got, Renee. You stay right on, and listen. I've worked in a lot of not so perfect situations, and here's what we do: we work with what we got. We work with what we got, and we'll make it happen. Okay. Okay. So, Nicholas, you get the idea, right? Now, so all of these extra ones that we haven't been using, try to use whatever you're being asked to do on here. You know, instead of using two formulas to get to it, take those two variables, and you find a formula that will directly get you to the answer in one step. And when you round the numbers, round them to the third position. And what that means is after the decimal point, you want to go 3 places. If it goes that far, if it goes way out, go to the third position, and you look at that number and underline it. And then the next one in the fourth position, if it's 5 or greater, then you round up the third position. And if that fourth one is below 5, you drop from the fourth digit over, and you leave the third one as it is. That's just the same rules in regular math for rounding numbers. So round every answer to the third position after the decimal, except for row 11. Row 11 with a star on it, and I put a note up there. Put the whole answer, because look, that number is so small. It's way down in the 4th, 5th, and 6th position. It's so small. It's a very, very small number. And so on that row, don't round them. Just put the whole number on there, whatever shows on your calculator. And in Moodle, you'll see the entire chart as one question. Okay. Now below it, you'll have a screen there. Set yourself up in that screen, 12 rows. And on each row, you're going to put 2 answers. So put 1 and then put 2 answers, and 2 and 2 answers. Set yourself up a chart. I didn't have an easy way to do that. And it was just something I copy pasted that chart in there. So just do it that way as far as putting your answers in there. And if you will, it's time consuming. But if you will actually show the formula, if you'll do that, if you'll put, that's what I will be asking for in person is the actual formula. So, say for row 1, put a 1, and then come out there and show the formula with the answer. And then if you have to come down another line, actually, if there's enough room to do it, then there may not be that way. But just put a 1 and then do 1 calculation, do the next calculation, and then show 2 where you start the next set. Just make it where I can tell what you've done. And just, be on the lookout on row number 11 that it's going to be. Now, another thing here is some of these numbers have K on them. So let's talk about that. For those of you that are going to be going on here, because I'm going to help Renee and I'm going to help Roger, whoever. Yeah, there are 2 people that haven't finished the worksheet that I can help now, and I want to do that. Actually, want to do that first. But Nicholas, right here, and everybody, wherever you see a K at, this says 6.8 K ohms. Now, you can't punch K into your calculator unless you're using scientific notation. It can be done if you got an advanced calculator, but it takes a few extra steps to do it that way, to punch that in. Just for simplicity, here's what you want to do. And listen, can you hear me good, Renee? Now, when you look at a number in this chart that says K, like 6.8 K ohms, here's what you want to do. You want to convert it into regular ohms before you put the numbers in the calculator. For instance, and here's how that's going to go. 6.8 K ohms would be this. You would move the decimal over 3 places and add zeros where you need to. So 6.8, if you were going to move it over 3 places, I've got to add 2 zeros to it. 6, 8, and then a 0, 0, And if I move the decimal over 3 places, it turns it into 6,800 ohms. So if you look at the number there, you see where the decimal is, everybody?
Yeah.
If you move the decimal over 3 places to the right, I go 1, 2, and 3. Then it becomes 6,800. Is everybody okay with that?
Yeah.
You are, Roger?
Yeah.
Okay. So the first thing you want to do is go through there and identify the ones that are in K. There's actually a couple more, and I'll just go ahead and show. I want you to tell me the one that says 130 K ohms. How do we convert 130 K into regular ohms so we can punch it into the calculator?
It'd be 130,000.
It would be 130,000 ohms, exactly. Now, again, the K can be put in a calculator, but you got to put it in there like this. It has to be 130 times 10 to the third, exponent of third, so of 3. So depending on what kind of calculator you got, you may or may not want to do that, okay? I'm just telling you that when I took electronics back in the 80s, we did a whole lot of calculations with K and micro and mega, and we did so many calculations that I actually did punch in scientific notation in the calculator. So I would put in 130 and hit the right keys to give me a times 10 to the third exponent. You know, and if you do all of that, and then when you hit enter, then the calculator is going to give you a number with an exponent. So it may say some long string of numbers times 10 to the third or times 10 to the sixth, and you got to recognize that exponent on the calculator on the answer, so that when you write it down, that you've included the exponent part of it. But for now, I would just, you know, convert it over to 130,000 ohms. So I'm going to jot that down here. So if you see on the screen here, those of you that can see, and Renee, you can go back and watch the recording too. You stay on the line here, but you can go back later and watch the recording. But here you see we've got 130 K ohms means 130 plain ohms without the K. So as you can tell that the K replaces three zeros. Okay. And the reason why that they use K is so that you don't have to write so many zeros. It shortens how many zeros you have to write in there. So that's the whole reason behind using metric prefixes in the electrical field or any field, is so that you don't have to put so many zeros in there. And it's a letter that represents 1,000, and we just know 130K, it means, you know, 130,000. So who can tell me what does, I'm gonna try you, Renee, being that you can't see, I'm gonna really put a challenge on you here. What does 2.2 K ohms mean in regular ohms? 2.2 K ohms. Kilo ohms. If I convert it to regular ohms, what would it be? Now, get you a pencil where you're at, Renee, and write down 2.2, and then put K down, and look, move the decimal over 3 places and tell me what do you got. To the right, 3 places. You'll have to add a couple of zeros to do it. Hey, yes, now you see, we can do this thing, and you're not even seeing what I'm doing, and you're listening good. So hey, let's give a hand to Renee here. Okay, great. So I knew we could do this. This Zoom ain't gonna stop us, Renee. I'm gonna tell you that. It ain't gonna stop this show here. All right. So that's exactly right, and you'll see that when you go into Moodle. And when you open up worksheet 2-2 in week number 5, you'll see this chart. And actually what I could do, Renee, I can send you a picture of the chart to your phone, to your cell phone. You want me to do that? Let me go ahead and do that right now. So while we're gonna make the best, of a situation that's not so that's not ideal, you know. Actually, I've already got, well, let's see, let's go. It's on the way to you. We're in this office in here. It's got metal studs in the walls, so the cell signal is a little bit weak in here, but it'll get to you in a few minutes.
Okay.
Matter of fact, let me step near the door just for a second. Y'all hang on, don't go nowhere. Let me step near the door so this thing can go ahead and get to her. Yep. Yeah, I'm trying to get a signal out of somebody, send somebody a picture. Yeah, okay, you out here sometimes get a text.
Oh, watch your feet.
Not one student can't get into that right now. We're actually doing it early with our college. While we're doing Zoom, I got one girl that's just coming in straight to a regular phone. You know, with no video. So we're gonna make it work. Okay, Renee, it said it went through,
Okay.
but I don't know if you can actually can you view a text picture while you're talking?
Yeah, but my internet came back on at the house.
Great.
Right, but can I still keep you on the phone just in case it goes down again?
That's fine. I'm gonna turn the volume
Okay.
down so it don't feed back.
Okay, that's cool.
Great. I'm fine with that. So here's what we were getting at, Renee, because since you kind of were not able to see there for a little bit.
Uh-huh.
The one you just told me about was this one. You see that?
Yes.
So you were correct. That you look for where the decimal is, and go exactly 3 positions over. So from here it will be 1, 1, 2, and then 3. And then here
Gotcha.
the decimal is understood to be right there where the 130 is at the 0 there. So you're just going to simply add 3 more zeros.
Gotcha.
And then with the 6.8, it's going to be 3 places from here, which would be there, 6,800. So punch it in regular ohms. And if your calculator happens to come up with an exponent, like a E minus 3 or a E plus whatever, that's an exponent. And it depends on what brand calculator you have as to whether it would do that or not. So if it comes up with an exponent, then you can write it out that way. Or if you want to go ahead and move that decimal to convert that exponent back to a regular number, that's fine. Whatever you're comfortable with. So if you're not sure how to convert it from an exponent, if it shows that way, write it down exactly like the calculator shows. Include any E's or any minus in some number after that sign, if it gives it to you as an exponent. Because and sort of what I'm getting at by exponent is, if I pull out, let me flip to the, well, I've actually got a paper I can just show you. This would be easier. I can point to it. So what we mean by exponents is this. Do y'all remember seeing this paper here?
Yes.
So the exponents are going to be, if I can get it right here. This is a little bit funny here doing this, but over in here. So for kilo, for instance, it has an exponent of 10 to the third. And mega has an exponent of 10 to the sixth. So what that means is that 10 to the third means 1,000 over here. The meaning of it is over here. 10 to the sixth means 1 million. And if it's giga, it is 10 to the 9, 10 to the 9th, which means a billion in our US short scale system, which means a billion. 9 zeros. The 9 zeros is the exponent. So if you punch in 10 to the 9th and it equals what on a calculator, it'll say 1 billion. 10 to the 9 and equal, it's going to say 1 billion. So, and then there are smaller exponents that you can also see, like milli. When we talk about milliamps in current, milli is a lowercase m, it's 10 to the minus third. And it means 0.001 or 1,000th of some quantity, like a milliamp or a milligram or a millivolt. So milli can be used for lots of things. In medicine, it's milligrams, right? So many milligrams of medicine. Well, in current, it's milliamps. In voltage, it's millivolts. And those are valid numbers that we use in the electrical field on small signals. And we even use prefixes that go down lower than that. Micro. Micro would be a millionth of something, and it's 10 to the minus 6. Nano and pico. No, micro, nano, and pico are used on capacitors to measure the capacity of the capacitance ability of a capacitor to store charge. Capacitors work kind of like a battery. They store charge, but not for so long. And but they're measured in a unit called farads instead of in ohms or volts. They're measured in farads as far as capacitance. And you would say a microfarad or a picofarad or a nanofarad. And so those exponents in the negative number are very, very small quantities that shows over here. It shows a decimal and then so many zeros and a 1. Everybody good with that?
Yes.
And so this chart here, your calculator can show you the exponent, the answer in the exponent, because there may not be enough digits on the calculator display to really show you the answer. So some of your newer ones, your more advanced calculators, they're going to actually, if that's the case, it'll actually show it to you in the exponent form. So and it may be some odd form. It may be some number and then and then an E minus 5 or something like that. And it would be like to the minus 5, 10 to the minus 5, some number and then 10 to the minus 5. So if you want to write it out that way, that's fine. Or if you want to convert it back to a regular number, you can. Whatever you're comfortable with. So for instance, like on a small number, like on milli, if you had some small number, I'll draw this out. Now take a look here what I've done with a milliamp. So I can if I have 1 milliamp as an answer, I can say 1 MA, or I could say 0.001 amps. Now on the calculator, for instance, it could say this. And then I'll stop on this. I want to let's see. So the 0.01, it could be 0.001 amps equals 1 milliamp, which could equal 1 times 10 to the minus third. So the exponent portion right over here times 10 to the minus third, that number could be expressed either way, right there. So if you see something on the calculator show up this way, or E minus 3, let's say if it says E minus 3, then it would be like 10 to the minus third. That's what it would mean. 1E minus 3. So let's just say that you may see something like that possibly. You might see a 1 and an E minus 3, something like that possibly. And if you see that, it's not an error, it's an exponent. Okay?
Gotcha.
You can just write it down the way you see it. Or if you want to convert it back to the to what this is, you would simply be doing this. You would simply be moving that decimal from that 1, moving it 3 places to the left. If it says E minus 3, you would start with a decimal, assuming that it's in the normal position of here, and then move the decimal 3 places to the left, and you've converted that exponent back to a regular number. Same thing here, 1 milliamp. If I want to convert to a regular number, I move the decimal 3 places to the left and drop the M. So the original place of the decimal, if it says milli, was actually 3 places to the left of where you see it now. And you would add zeros if necessary and drop the prefix, drop the M, the little M, and then you're back to regular amps. So 0.001 amps equals 1 milliamp, which would equal 1 times 10 to the third amps, or 1 E minus 3. You know, so all that means the same thing. So if you see some strange number show up, because in here in this chart, you're going to get some super small numbers that are like very small. And just to give you a quick glimpse, I'm not going to leave it up here, but do you see something like that already? You see how small some of the numbers are here? Some of them are going to be like really small, okay? I'm not going to leave it up there long because that's the answers, but I got to see your work anyhow, okay? So show your formulas. Show your formulas. So in Moodle, you know, in the screen you have below this, make your rows and show the complete formula that you're using. And for 2 reasons. To show me that you did do it, that you understand it. And another reason is that if you happen to get anything wrong, and you may get it 100% perfect, but if somebody made a mistake, and I look at their formula, then I can make a comment on what they did wrong. I can, if I see your work, I can make a note. Like if you were in person doing a paper copy of it, I would take a red pen and I would make some little comments and say, well, you forgot to square that number, or you didn't hit square root button on the calculator, you know, for instance. And then you can kind of know what went wrong instead of me just saying, well, it's wrong. You know, I don't like doing that. You don't gain like that unless you really know, well, what went wrong. So my goal is for whatever you're doing, if you get anything wrong, is that we discuss it and that you understand completely what it takes to really fix that problem. And then you're 100%, you know, you've got it 100%. Then there's nothing left that's foggy, you know. I don't like moving forward when something's foggy for anybody. It's not.
Hey, Derwin.
Yes, sir.
If we work out on a piece of paper, can we take a picture of it and send it to you through your email?
Yes, sir.
Right.
If you want to do it that way on paper, snapshot it and email it to me, and just put in
which paper it is.
In the subject heading which one it is. Yeah, that's fine.
And the class, I'm assuming too.
Yeah, it is. That'll work.
All right.
Yeah, because I you know, and that may be easier for you than typing the whole formula in, but it's, yeah, that'll work. So that, you know, that gives you a heads up. You know, be expecting, you know, when you do this, be expecting, you know, try to go whatever variables you have, try to use those two to get straight to the unknown answer directly in one step. And so in that process, if you pick another one, for instance, yeah, let's just take, say, number, well, pretty much, I'm gonna find one I know for sure is gonna be kind of odd that way. Let's take row number 9, for instance. I'm gonna let you tell me what would you do. So row number 9, you're given voltage and you're given wattage. Now, how could I find the resistance directly when I have the volts and I have the watts? I got volts, I got watts, and I'm looking for R. So we're looking for R. So let's go to that quarter of the pie chart. We're looking for R, right?
Mm-hmm.
And so I have three ways to get it. So which one can I use?
Divide E over I.
Okay, we're looking. Hey, McGill, how you doing?
Hey, Mr. Derwood.
Glad you made it. Let me get you check marked in here. And McGill, we are recording, so if anything that you missed up to now, you can go back and watch it later.
Okay.
All right, now. So we were looking at what? Row 9. We got voltage and we've got wattage. Got watts and volts. And we want to find resistance.
Would it be E squared over P?
Yes. Or when we have volts and we have watts, volts is E and P is watts, it would be the voltage squared divided by the wattage, and it would give you the resistance directly in one formula without using some other formula to get to it. So I want you to use these formulas that we have not been using. And what it's going to do is your answer is going to be more precise than if you use some other formula to be able to get to it. For instance, if you didn't go directly using E squared over P, then here's what someone might would do if they wanted to stick with the triangles. Let's say you've got P and you've got E, right? You got power in volts. And let's say, and they said, well, I want to get ohms. So a person might well say this. You could do this. You say, well, I want to get R, you know, and I've got E, but I don't have I yet. So to get R, I've got to have I, right? If I'm going to use a triangle. Everybody okay?
Uh-huh.
So I don't have I, and you might say, well, I got to use I. Then I'm going to come up here, and I'm going to say P over E. P over E, you know, P over E is going to give me I, right? So you might go in there and do P over E to get I, and then take that I, and when you get that I, you're probably going to round that number, right? And when you round it, you're going to lose a little bit of the accuracy of it when you throw it into a second formula to calculate again. So your numbers kind of start to drift. They can drift depending on, you know, how far out you round, okay? So, but I mean, it can be done that way. But again, you know, you're doing P over E to get I, and you're taking that I answer, and you're coming down here, and then you're saying E over I is going to give me the R. You see what we did there? So we did it without even going into the pie chart. But that's not good. You don't want to stay hung up on the triangles. The triangles are just only good to get you started. And from that point, it's the best thing is to focus on that pie chart, because the whole picture is there. The whole picture is there, and whatever you need is in there. And it's faster. It's more accurate. Okay. So everybody cool?
Yes, sir.
And you've
Yes.
even got, you know, there's a power times resistance. You get that answer there, and then you hit the square root button. Now be careful. Some calculators, you have to hit the square root button before you put some number in there. Some of you are going to put a number and then hit square root. So the way you could test that out would be to put a number in there like 9. Say 9 and hit square root, and it should say 3. Okay. Pick some number that you know what the answer is going to be, and find out, does your square root button have to be hit before or after the number? Okay. Let me just show you, for instance, like on my phone here. And I know on my phone is different from other people. I've seen in the classroom to where it was actually backwards from some folks. Degrees. Now, just to show you right here on my phone here, to be able to see those other buttons in there, I got to hit that little arrow there to bring those other ones in. You see that?
Uh-huh.
So let's find out what would it take to get the square root of 9. And I haven't done on here in a while. Let's back out. Let's try if we do. Let me change the angle here so I can see what I'm doing. So if I close that out, I've got to hit that arrow there to get back to the numbers. So if I hit 9, hold on. Good gosh, this is so awkward here. Let me move the camera. This is just so odd the way I'm having to handle this. Awkward. Get the camera right in front. Now, so y'all see my camera pretty good?
Yes.
So if I say 9, and then I go in here and I hit square root, and I hit equal, bad expression. You see that? So it doesn't work that way.
Yeah.
Right, so you go back, and I'm going to get rid of that. and I'm going to say that whatever numbers I had to do, if I got to multiply two numbers together, I would multiply those. Let's go in here. Let's hit the square root sign now. Square root, and then back out and hit 9, and it make it look literal the way it's going to be on paper, and hit the equal. And well, actually, it just told me I didn't even have to hit equal. You know, I hit 9. Hold on, back out. Go into here. But mind you, have to bring that screen out. You got to hit the square root sign and then close that, and then hit 9, and it shows you the answer directly without hitting equal. Everybody got that?
Yes, sir.
And then as
Yes,
far
sir.
as squaring a number, you know, if I say 3 squared, 3, and where's the square button at? The last phone I had, it had a complete scientific.
Go to the settings at the top right.
That's unusual that it doesn't have it in there.
Well, there's an app that you can download called Wabbit, I think it was called. It's a
Right.
scientific calculator.
Right. So you bet for me, if I was going to be doing it on the here, I would need to download an app that gives it to me. But if you don't have it on here, you can say 3 times 3. 3 times 3 equals 9, and that's like 3 squared. Okay. 3 times 3 is the same thing as saying 3 squared.
Try swapping from the right. That blue bar on the side there.
See, it has the E in there, and it's got, wait a minute, that right there, I think that's going to be it right there. The up key.
Yeah, you can type
Let's-
in a
let's-
number and then
And then you
retype
type
it
the
in there.
number after that. That's what that's going to be. So let's just try that. Let's go back. Let's say 3, and then we go into here and we raise it, and then put 2 in. And yeah, that's what you do. You got to raise it when you square it by 2, and it's going to be 3 squared. You see that?
Yes.
So 3 squared is 9, right? And then 9, the square root of 9 takes you back to 3. So that's the way those numbers work. When you square a number, it's the number times itself. And then when you do the square root, it takes you right back to the root of it before it was squared. You know, so you go back into there, you can get the square root sign, and if I hit and close that out and hit 3, wait a minute, we didn't want to do that. The square root of 3 is 1.73. That's something for 3-phase power. We don't want that right now. That's for you're going to see that later though. You'll see that later in this book, the square root of 3 for real. So it's just coming on voltage drop calculations. Let's clear that. The square root of 9 is the easy one. Would be 3. You know. Okay. So everybody cool with that?
Yes.
Yes, sir.
Yes, sir.
That's just kind of a heads up on what you could see. If you got another kind of calculator, let's see if I can lay my hands on. No. The other one I have is a Casio. No, I'm trying to remember where is it at. Move this around here. My regular Casio calculator is out of position right now. I don't want to tie your time me looking for it, and I'm not going to mess up your time. I've got one somewhere. It's just a regular handheld calculator. It's got all that stuff on it. Here it is right here. I knew I had it. This is one like you can get in the bookstore, and we'll go over it real quick. This is important to do this. If you've got a standard calculator, because personally, I would not be sitting there fiddling around with all those extra button pushes on my phone, because there's just too much. There's just too much to it. So the Casio, let's get my camera. Yeah, okay. So here we go. You see this one here? So with this one, if you say square root, and then, can y'all see the calculator pretty good?
Yeah.
Yes.
And then
Yes, sir.
9, and I just hit equal, it's going to say 3. So you put the square root sign first, and then the number, and then it's going to come out that way. And then to square a number, it's going to be x to the 2. So if I say 3 and then x to the 2, it puts a 2 up there. So it raises it to a 2, and then I hit the equal, and it's going to say 9. So everybody see that? So this is much faster. It's just much faster. And that calculator ain't but about, I think maybe about $11 or $12, something like that. It's not very expensive, but it's got everything in there. It's got all your trig functions in there. It has everything. You can do exponents with it. I won't, let's see. What was the, it will cube a number to the third instead of to the second. And then x, no, that's to the -1. That's not it. The one you could do any exponent you wanted to, times 10 to the x, right in there. That's a second function. You have to hit a shift key, and like 1, if you hit 1, and then the shift key, and then 10 to the x, and then I do a -3. A -3. Let's see if that converts it over to 0.001. It did. See that? 1 to the -3. Now it didn't. It's not going to show a 0.001. But this is what you can enter. You can enter scientific notation this way, and do calculations. You can, hold on, times 2, and it would be that. So you can put scientific notation in and multiply it by other numbers or by scientific notation, and it'll give you the answer in that notation. You see it? You get 2 to the -3 there. That's what I was getting at. But some calculators might say, well, instead of saying to the -3, it might say E -3, instead of really raising it up like that. Everybody get the idea?
Yeah.
Yes.
Okay. So that's kind of enough said about that. It's a lot of extra button pushing, but basically what I would do seriously is if you just simply convert those numbers, that 6.8 over to 6,800, you know, you calculate, you just put it in there 6,800. Now what's this thing doing now? I was hitting the decimal. I put it in there as a plain number, and you're not having to deal with any extra button pushes that you know that may be awkward, or you know. See, on mine, to get scientific notation, you got to go second function of the log button, 10 to the X. I got to go up there and hit shift and do that. This is just way too much trouble. The calculator I used a lot of years ago that did it easily was a Texas Instruments. It was a TI, whatever it was. It was a Texas Instruments calculator that you didn't have to do second function on much of anything. You had enough buttons on there that you could do scientific notation directly pretty quick. So, but anyhow, that hopefully that'll help. And this has got a nice little it's solar and battery. It's got a little case to go in the front of it, so your keys don't get messed up. I think they should still have these in the bookstore. They may have something better in there.
If they don't, they got some at Walmart.
Exactly. Walmart's gone. Exactly. Okay. So now. So everybody should be fine, you know, knowing that, you know, try to find a direct formula in here. These ones that we have not been looking at, try to use the ones that we haven't been looking at, you know. This one, the P over R square root, and so on. Use every one of them. Use whatever will give you a direct answer to whatever you're looking for. Just use a direct formula. Okay. So with that being said, there. Let me ask you, those of you that have not finished the worksheet for series circuits. I want to help you now with anything you got trouble while we're online. And so what we can do is I'm going to flip to the worksheet, and you tell me which one that you would like to go over as a group, and we'll do that now. So I'm going to flip over to the worksheet itself for chapter 3. So like there's question 1. Did anybody have trouble with question 1? It says explain the 3 rules for series circuits. Now actually there was
I didn't.
That's Nicholas, isn't it? Yeah, Nicholas got his right. Now, how about anybody else? I noticed that there were some people that turned the worksheet in that did not answer that question appropriately. Okay, so McGill, can you tell me the 3 rules for series circuits? Now let me help you here. I'm going to flip to the PowerPoint, and I'm going to show you those 3. So it'll be, and it may be the way the question is worded. It may be kind of. So let's take this and let's go to the PowerPoint real quick for chapter 3, and let's find those 3 rules. So if I go here, now you see, do y'all see the PowerPoint?
Yes.
So this is the first rule.
The voltage. Oh,
Right. The total voltage equals what, McGill?
so what?
The first rule is this one. Do you see this on the screen here?
Yes.
Now, what does that say?
What is that? ET plus equals E1, E2, E3.
Well, it equals E1 plus E2 plus E3.
Yeah.
Now, okay, and you might be thinking, well, what does that mean? Let's take a look at the circuit. Let's look at it on a real circuit here. So these little circles up here would be a meter, a voltmeter. It would be your test meter placed across that resistor. So E1 is nothing more than a meter, okay? When you put the test lead, you put them test leads across that 4-ohm resistor, then the display would be E1. Whatever shows up on the display is going to be E1. And I move it over and I go across the second resistor, whatever the display says in that little circle up there for E2, that's just going to be the display on the meter. Okay, everybody follow? It's the measurement. So E1 is the measurement across resistor 1. E2 is the measurement across resistor 2. E3 is the measurement across resistor 3. And the ET is E total, and that's just going to be the power supply. So y'all know that from even in the shop Tuesday, what did you see on those light bulbs? You know, we had 4 light bulbs in series, and we had 120 volts at the power source. So how much voltage did we have across each light bulb? There were 4 of them, and you had a total of 120 at the beginning.
Are you talking about
30?
being?
It was 30 volts across each one. You had four light bulbs in series, and you had a total of 120 volts. So each bulb used or dropped 30 volts apiece. And so look, when you add them up and you say E1 plus E2 plus E3 plus E4, you had 4 bulbs. So there was 4 E's in there, right? So 30 plus 30 plus 30 plus 30 equals what? 120, exactly. So that's the rule. In this case, on the PowerPoint, it's 2 volts plus 2 volts plus 2 volts equals 6 volts. So that's your first rule. Everybody good?
Yeah.
Yes.
And when you answer it in modal, you can simply type it in. You can say ET equals E1 plus E2 plus E3, and that's fine. That really states the rule. You can do it by actually just putting the formula in there. You know, but you can put it in word form. The sum of the voltage drops across the individual resistors is equal to the total applied voltage. You know, you can say it, or you can just put it in a formula. It's easier just to type the formula in, you know. And then the next rule would be, you know, we know that what can y'all tell me about the current, the amps in a series circuit? Who can tell me the rule about current?
Since there's only one path for the current stays constant throughout the whole thing.
Exactly. So this is our second rule. And if you read it, well, what does it say real specifically? Who can read it real careful there? What does it say? When you look at the eyes there, if you can kind of, somebody read the formula itself, what does it say?
Are you
IT.
talking about IT? Go ahead, Roger.
IT equals I1 equals I2 equals IN.
And the IM would be however many of them you have. It could be any number.
Mhm.
So here there's an equal sign between them. There's not a plus sign, right? Which means that the current flow coming from the power source, it equals this. It's the same current, the amount of amps that goes through all of the resistors, which would be, you know, here, you know, you're seeing that same current goes through all of them. So it's not going to be, you know, 1 amp over here and 2 amps over here and something different. It's the same exact flow rate in amps in that circuit. And you can actually think of it like a water line. If you had a closed loop water pump system that was pumping water at 2 gallons a minute, and the water was going through 3 different things that was using water to maybe cool them, for water cooling, okay? And you have a pump here, and it's pumping 2 gallons a minute. And I've got 3 pieces of equipment in a plant that are being water cooled by a closed loop water system, okay, to get heat, to draw heat out of the machine. So I've got water flowing through here, 2 gallons a minute, and then 2 gallons a minute. It's 2 gallons a minute no matter where you check the flow rate, isn't it?
Yes.
So when you look at fluid power like water or hydraulics or anything like that, the gallon per minute in flow rate is the same exact thing as amps is in electricity. Amps is the flow rate of electrical charge per second. So it literally is flow rate, and the flow rate of the charge in that closed loop circuit there, that flow rate is the same over here as it is through any one of those lights, and even through the battery. The flow rate is just the same. The battery would be the pump, okay? So, you know, whatever that flow rate is coming out of that pump, it's the same no matter where you are in that piping system. So, okay. So that's rule 2. And you could put it in that form. You could say IT equals I1 equals I2 equals I3, whatever. And that's your rule. I mean, it's just that simply put. And then our third one would be this. And who wants to read that one? Y'all still there?
The total resistance in a series circuit is equal to the sum of all the resistances.
Right. And so you can put it down in a formula format. In your rules is R total equals R1 plus R2 plus R3 plus. So everything's plus. So those resistances, you know, when you look at them, here you have R1 plus R2 is going to equal, you know, 4 plus 12 is equaling 16, and that's your rule. So no matter how many of them you have, you just simply add them up. There you got a total of 12 ohms, and so that's your rule. Okay. And again, some people, when they did it in Moodle, they put a different kind of answer. They put, instead of answering with those rules, they simply put the word voltage and current and resistance and didn't really give rules. They just put current, volts, current, and resistance. And so I sent an email when I see something like that, and I know that the question was not clear. I will usually do a screenshot and send you an email right then to try to help you to clear it up. And so that's what I did on those, is for folks that the question was not clear evidently, and it's okay. And so I tell them, you know, if once you submit the worksheet, and it doesn't let you go back in there. If I see something like that, I'll send you an email. If you send me the correct answer, then I'll just paste it in there, and you'll be straightened out. So okay, so let's stop this one, and let's go back to now. Renee or Roger, which other ones in here in this work? Do y'all see the worksheet show up again?
Mhm.
Which ones would you like to go over? Would you need help on?
Yeah.
If any.
I just haven't looked at the worksheet. That's all it is.
Okay. Renee, do you have any questions on any of them? Would you like to let's do some of them together? We can do any of them, do all of them together. I mean, it's fine with me.
I don't really have any questions about it.
Okay.
Just
good.
having time to actually do it.
Gotcha. I understand. Okay. All right. So what I was offering to do was during this session, if you wanted to go over any of them, I was just concerned that if somebody needed help, that we could do it now, just like you being here. You know what I mean? If you pull it out.
Yeah.
So do you want to try one? You want to try one now that you hadn't done and see? Or are you do you need to do you need to get out of the session to go get ready for work? You just tell me. This is to try to help you to make sure that you're going to be good to go. My goal was to get everybody finished on series, and then next week we could, we would be on lab time. You would be doing the series circuits and all. But as far as in the book, the next thing in the book would be parallel. I didn't want to start parallels until everybody was done with series, because it's going to be the rules are the rules are totally different.
Yeah, I've just been catching up on the worksheets right now. But
Right.
yeah, I have been paying attention.
Okay. Right.
Good Lord.
Well, since there's only 3 of us in the session right now, how can I help you? I don't want to go into chapter 4 today. It wouldn't be good to go into chapter 4 today, because it's better to do it when we got more people in, and you really need to be completely done with 3 before you hit 4. Okay. The formulas are
Okay.
totally different. Okay. So
All right. So
what I can do, I'm going to give you an option of this. I can either stay on and keep the session open and help you do them through the webcam, or if everybody is completely confident they can finish it and they would rather do it later, then I'll just simply end the session. And because we don't need to go into chapter 4 right now, we just don't. That needs to start next week. So you're better off while the rules are fresh on your mind, because it is kind of tricky when you get down to say, for instance, let me kind of test you here and see if you can tell me something. So let me enlarge the screen here. I'm going to see if y'all can help me solve this one. Do y'all see that circle on the screen?
yes.
Now, okay, I want you to, if y'all will, see if you can explain to me completely, without me giving you any hints at all, if E2 equals 54 volts, what would E1 be? The voltage reading with a voltmeter across the second resistor is 54 volts. And I want to know what would the voltage reading be across E1, and we don't even know what E total is. and it's not even asking us that at all. It just wants to know, you know, what is E1? And I'm just going to be real quiet and listen to see if you can make sure that because this stuff throws you a little bit of a curveball.
What the hell?
Now, I will say this, that when you get questions like this, you've got to do an indirect calculation to get some number that you need to come back and solve that problem. So it's going to take a side step to do something to get some number to come back and answer that question. If that makes sense. Any ideas?
So you have to find the amps first.
Exactly.
I just got to remember what each of them mean. Each of the letters means. That's about the only problem I have. I have to look it up every time.
You're trying to figure out what now?
I just have to remember which each of the letters mean.
Yeah, E is going to be voltage.
Voltage and let's see, I's.
Mhm.
E divided by R.
If you just want to go to the triangle, you can on this one, but
6.
it's right there. You know, it's right there in the pie chart as well. You know.
6.
So what's the first step that you would do, Roger, in solving this? We know that there's 54 volts across this one,
Mm-hmm.
and we know that there's 9 ohms.
Mm-hmm.
And you said we're going to find the amps.
So and amps is 6. It looks like.
So how did you come up with 6?
54 divided by 9.
54 divided by 9 is giving you 6 amps. Okay.
So you'll take the amps. And I gotta find the volts for the other one. That so
Exactly. You see what we're doing, Renee?
Yeah, because I just came up with 6 amps too. So now
so
You
it'll
got
be
6.
I
Listen,
times
that 6 amps is
I
flowing
times
through the whole
R
circuit, isn't it? 6 amps is flowing through the whole thing. That's what's
3
common.
be
And we know
18.
6 amps is flowing through R1 too, right?
It'd be 18.
And how did you do the math?
54 divided by 9. 54 is the voltage for E2. 9 was the ohms for E2, and then I times 6, which was what I got, by 3, which is the ohms on 1. And I got 18.
Right. So you calculated the 54 divided by 9, 6 amps. And we know there's 6 amps. So that gave us a second unknown. Okay. Here you have 2 unknowns. You have 3 ohms, and you don't have a clue what the amps is or the volts. So you can't solve anything until you've got 2 variables that are solved, that are answered. You got to have 2 things to get an answer always.
Mm-hmm.
So when you're missing, when you don't have those 2 variables there, you got to get it somewhere. So you can get it from over here, you know. And that's the idea. Is that there's more thinking involved in this end of it. You got to go dig somewhere else to get something to solve this one. But that was exactly, you know, what it's supposed to be. Okay. Now,
I'm gonna be honest. I understand that. I pretty much know that the triangles are like a simplified version of the circle, and you can get everything that's on the circle from the triangles, right?
right. But when you look at the triangle, when you simply look at the triangle, and you go, for instance, and you say, you know, we know that the E, if I cover up E, it equals I times R, right? If I cover up E, it equals I times R. We'll look up here. E equals I times R. It's right in there. It's the center formula in that quarter of the chart.
Yeah.
So when you look at a quarter of it, at this quarter of it here, then
It'll
you got
tell you what it'll be for both of the triangles, right?
exactly. So yeah. So here, each triangle contains three formulas that comes from the pie chart. So if you break that down and you look at E, if I cover up E, it equals I times R. So look, E is I times R. Now if I cover up I, it equals E over R, right?
Mm-hmm.
So look, I is E over R. This camera is playing games with me here. Let's see. I equals E over R. See that?
Yeah.
When I cover that I up, it's E over R. Look, I is E over R. So it's this one. And then the third one, if I cover up R,
E divided by I.
it's E over I. Look, R is E over I.
Mm-hmm.
So now the other three out of the power triangle here is you have that if I cover up P equals what?
I believe that's I. Oh, hang on. That E times I equals P.
Right. So P is E times I. Right there. See it?
Yeah, I understand that.
Right. And then you got the other two. If I cover up E, you know, E is going to be P over I. E is P over I. And then the last one.
For the square root ones, they're like I equals this. I reckon that'd be P over R, the square root of that.
That's right.
Okay, and then for E, the P times R, that'd be the square root of that, right?
Right. You want to do the calculation in there first. Say P times R equals what?
And then put it in a square.
Right.
Yeah.
Exactly.
Okay. I was just checking.
Yeah.
And how would you know that from the triangle, or could you do that from the triangle?
You can't do it from triangle. It ain't in there.
So that's what you're trying to tell us?
I'm trying to tell you that pie chart's what you really want to look at from here on out. You want to be aware of everything that's in there.
Okay.
This was just to get you started here. The triangles to get you started.
Gotcha. See, I didn't understand that before right then.
Right.
Is there any other the calculations that you can't get from triangle that's on there, or the formulas?
Well, you know, you can get three calculations in here, and you can get three up in here, and that's it. So you get six formulas out of the triangles, but they all come from here. And then there's no way for those other ones to fit in a triangle.
Gotcha.
Yeah.
All right.
Yep. So this class is so important. And I know you're taking it as your last electrical class, right, Roger?
Second to last, I believe.
Second to last. Okay. You got to get motor controls in January.
Yeah.
But this class is the best way to get it is to get it first, is to get it before you get anything else, or get it while you're getting residential, and those two go together pretty good, because this is the foundation of everything electrical. And I don't care, you're talking about maybe going in the military, man.
Mm-hmm.
If you understand this really good, they're gonna like that. They're gonna like it. That this already. They're not gonna have to teach you this.
Yeah,
But
I believe they send you to tech school to learn all that stuff in case you don't know it.
Right. Right. They'll test you and find out what you know and what you,
Yeah.
and you know, and then they'll train you from there on out. But if you already know this, they're gonna like it.
Mm-hmm.
Those jets and everything and helicopters and all that stuff, all those control systems, man, everything works on this. Everything is based on these rules. It's you know, and when you troubleshoot the systems, you need to know this. If you don't, you're going to be lacking. I mean, you're just going to be lacking when it comes to reasoning out different kinds of problems. When things are not right, it's hard to understand where do I go unless you understand Ohm's law is a part of your foundation in being a good electrical control technician or engineer.
I got you.
Yeah, so it's this is very good stuff, and it's you can't really go without it, and get you won't get real far without it, honestly. And then so let me ask you this one, Renee, what would you do? How would I answer the question? Find E total in this one. And you see what we know. We had the I total, and we've got the different R's, but we don't know anything else. We don't know anything about any voltages there.
I'm sorry, say that again. You're lagging. It's lagging really bad.
We want to find E total.
Crap. I don't have time to go.
We don't know what
Okay.
we don't know what the power supply voltage is, but we know what the total current is, and we got the resistances of these three resistors, and that's all we have. We got I total and the different R's, but we don't know anything about no voltage drops, nothing. And we've got to solve and figure out what is the power supply voltage.
Okay, so we would have to solve for the voltage on each individual Lord, what's the word I'm looking for?
Resistor or load.
Yeah, so we got to solve we got to solve for load on each one, because the total, isn't it all of them added together?
Exactly. Now I know that you.
So we
you
got to
that
solve
rule.
each one.
Yeah, you've got that rule.
Yeah.
I'm happy. I love to hear that. That's good. That's where if you don't know the rules, you don't have a clue where to even go at all. That's why we're not going to go into parallel now, because parallel is a whole different thing. When you get all the way with this, it's when we get parallel. So how do we do it? Tell me how to do it.
Okay, so I'm going to my 3 amps, and I've got my 8 ohms for circuit 1.
Making me a little note card real quick. Tired of having to look at what everything means.
What'd you say, Roger?
Making me a note card real quick because I'm tired of looking at what each of them letters mean.
Right.
Mr. Durwood,
Yes, ma'am.
is that a 0.3 or just a 3? I can't really tell.
It says 3. It's just a plain 3. It's kind of fuzzy. Let me enlarge it a little bit.
You can always go to the worksheet in Moodle if you can.
Right. Yeah, it's just a plain 3.
Okay.
That's a good question.
And then 3 times 24.
We're gonna let you teach us, Renee. If you can explain, give us how do you do this?
Okay, hold on. Okay, all right. I hope this is right. So, to get my total volts, I have to know what each of them are because the 3 of them would add together to give me my total.
That's right. Exactly.
So, for the first one, I have 8 ohms and I have 3 amps. So
Right.
I multiplied those together and I came up with 24.
Okay.
Okay. So then I moved on to 2. 3 times 16 is 18. And then the third one is 3 times 12. It's 36. So I add those 3 together and that gives me my total voltage of 78.
Exactly.
Yay!
Yay. Okay. Now
Voltage.
how about this one?
So I've got the total voltage.
Why don't we get Renee? Why don't you do E1 and Roger do E2?
Uh,
And y'all explain. Teach me. Teach me. What do you do?
I'm writing down the meetings real quick.
So if you look here, kind of think about this. You got a resistor, but you don't know the volts and you don't know the amps. So you got two unknowns. The same thing there. You got resistance. You don't know the volts and you don't know the amps. But you've got the main power supply voltage. And so you can still step over to the side and we actually kind of look at the bigger picture. And so where do we even go from here? You know, where do we start?
Okay, well, if we know that we have 10 ohms and 30 ohms, you can add the ohms together and that gives you your total ohms, correct?
Exactly.
Okay, and then we can just use, well, then I don't know after that because then,
You're on the right track. You getting ready to get it.
Oh, what was P equal again?
P,
Yeah.
well, it depends on what formula. We're not looking for P here now. Oh,
No, I was making a note card.
Wattage.
Wattage.
P is power in watts. And it can be in volt amperes. VA is like watts. If you see transformer, yeah.
Is watt spelled with 2 T's or 1 T?
Two.
Okay, just make sure. All right, power and watts.
You can look the guy up. Look up. I think it might be Alexander Watt or something like that. It was every single electrical measurement that we do is named after the last name of an electrical pioneer back in 1800s. Every one of them. Volts is after a guy named Voltaire. Ohms is after George Simon Ohm. The ampere is after some French guy, last name Ampere. And then the watt is the last name of a guy named Watt. I don't remember his first name, but all those guys you can read. And matter of fact, I've got a book. I need to make a copy and show y'all and give you a copy of all these pioneers. I've got a book that shows all of them together in there. Tells you when they were born, when they died, how they did their discoveries, and it became accepted and all. And it was all of them. Every one of them are European. German, French, they're all European. And I think pretty much most of them were physicists. They were physics, like doctors and majors in physics. And they are the ones that really define and give us all of this that we can understand it. So you can kind of wrap your head around it. But anyway, Renee, you said that you had 40 ohms as our total.
Yes.
And that's going to put you, that's got you a step in the right direction. What can you do with that 40 ohms?
With that 40 ohms, I can
total ohms, you got total voltage.
Run the total amps.
Right.
And then I could.
Absolutely.
Okay.
When you get total amps, then you can go back and answer those other two questions. All right. So what would I total be?
I'm coming up with 3.2 because it's 128 divided by 40, correct?
Right. And you got 3 point what?
3.2.
That's right. That's exactly right. And then what do you do with that number?
Then I can go over there and I can say 3.2 times 10, and that's going to give me my first voltage.
That's exactly
right. And then
right.
3.2 times 30 is going to give me my second voltage.
Exactly. Yes. Precisely. So that's why it was good today for us to do exactly what we're doing right now, because we can do a lot in Zoom that's basically, we can do the lecture almost like being here, as long as you'll talk and we're talking back and forth. We can still do our book portion and be very effective like we're doing right now, making sure you're getting it. And go ahead.
I got 3.2 for the amperage. So we're supposed to find the voltage for E2, right?
For E1 and E2.
E1 and E2. So the amperage is 3.2, and so you use ohms and the voltage, right? For ohms and the amperage.
Ohms and amps, yes.
Okay, so INR.
Right. So somebody tell me what is E1?
Oh, INR time. So that right there times 30. Okay, 96 volts, I believe.
So I got 32 for the first one, and then 96 for the second one, and then you add them together because you got to make sure that you come up with the 128, correct? And that's the way to double check yourself.
It is. Now, what'd you get for E1?
I got 32.
Yeah. Okay, that's fine. And like you said, you can double check yourself by adding those up, and that's going to tell you, did you do it right?
Yep.
Yeah. Now I'm satisfied that you understand what to do. Now I'm satisfied that you.
Normally I can figure it out. It's just I just don't do it all the time, so it usually takes me a minute.
Right. And that's what I'm here for. I get paid to help you with it, to go over, and this is our time, and it's time well spent. Whoever's watching, recording, they can benefit by hearing us like we're doing, because again, there was about 5 people that had not done the worksheet, and that was my concern. My number one concern is everybody catching up this week.
I'm gonna be honest. I don't mind the math and stuff. That's the easy part for me. It's just getting through all the writing part and the word work.
Yeah.
That's what I was having trouble with. I'm getting through it though.
Good. There's a lot of paperwork in the military. I ain't been in there, but I just know they're going to be.
Oh yeah, that's the only problem with getting up and rank and whatever. You got to do a lot of paperwork.
there'll be a lot of, but I'm sure it'll be probably computerized, where there'll be probably very little on real paper. It'll be a lot of computer typing, and you know. Yeah.
But you never know.
Yeah, I'd be glad. I'd be happy to see you go in, and then I don't know of any students that's gone in the military that I know of.
The only thing that I think would hold me back right now is the asthma I used to have. But as far as I know, it ain't affected me. I haven't had problems with it since I was like 13, 14, so it shouldn't be a problem.
If it's something treatable by regular medicine, I'm sure they would, you know.
No, it's I believe if you've had problems with it like in the past 5 or so years is what they're asking about. And
Yeah.
I need to get that stuff from the doctor, and I'm gonna have some tests done and make sure it ain't a problem.
Yeah.
That's why I missed the class last time. I was at the doctor, and I thought the appointment was gonna be real quick, but it took them about 3 hours.
Uh-huh.
And they didn't even answer half my questions because evidently they don't have all my records in this. You know, you'd think that the doctor you've been going to for a while would have all your records, but evidently not.
Have all the records from other doctors, you mean?
Evidently not.
They don't get them unless they ask for them, you know.
Yeah.
I had a new doctor I'm taking my mother to in the morning. I told y'all in the beginning about my mother's going to have part of her colon cut out.
Yes.
Well, a nurse called me this morning and she said, where was the imaging done on your mother's colon? And see, she didn't even know that. And I had to tell her where. It was done at the diagnostic center. The CT scan was done here, and then the colonoscopy was done at Sampson Regional. Well, this nurse didn't have that written down, which you thought that somebody would have told, but she didn't know. She says, well, I want to make sure all the imaging is here, so when you're here tomorrow that we have everything in place. And I said, well, great, you know. So
yeah.
What they told me was it was like in a different system from like, because I was looking for like where they initially told me I had asthma. Evidently they didn't have a record of it. I was like, well then I called my mama. She said something like 2002. The other doctor said that's about when you had it. I'm like, okay, I told her that she wrote down. I'm like, is that okay? She's like, yeah, that's fine. I'm like, okay.
Uh-huh. Now, it's almost time to close here. We've got 1 minute. Let me ask you this question here. How would y'all solve this one right here?
Probably within 15 minutes.
Can you give me a quick way? Kind of just tell me which way you're going to go with it.
Let's see, there's
Okay. All right.
E. Let's see, you got
Roger just tells it like it is, Renee. He tells it like it is. I like Roger.
Can you go up a little bit? I
think that's everything on the question day. I mean, everything.
That's everything. Okay. Yeah, that's everything on. Okay.
We're looking for E1 and E3. Yeah.
I haven't been writing any of this stuff down. I'm trying to do it in my head because I'm on a little bunch of paper right now. So, am I solving for E3 or are we doing both?
E1 and E. Well, yeah. If you want to do E3, let her tell me on E1.
Okay. All right. So 14.
Trying to find volts, right? So, okay, so it'll be fine.
Y is constant.
20.
Four.
So would it be 20?
Yes.
Okay.
I came up with 6 volts for E1.
Well, how
Okay.
many?
6.
I got 8.
So,
Wait, you're right. I don't know where I got 6 from because 4 times 2 is 8. I
right,
don't know why I was thinking.
right,
My bad.
right. You got it. You got it. Yep.
The hardest part is finding the formula.
Right. Well, what
Yeah,
this does is
there's a lot
it
of
gives you,
formulas.
it gives you, it gives you, you got to kind of go over here to get some information and solve, and then come back and do, then get the answer. So it makes you, it finds out, do you understand the rules of series? You know that current there through R2, that's the answer. That's what gives you the stepping stone to go to the next thing. But you know that it's the same current through all of them, so you can use that to answer the question. Now, when you get to parallel, it's going to be a whole different thing. The current is going to be different through every leg of the resistor, but then the voltage drop is going to be equal across every one of them in parallel. Everything changes radically, So that's why we're doing what I wanted to do today is to make sure that you could do this worksheet and be completely finish it this week. And then we'll flip over sometime next week. We'll flip over on parallel. The way it looks right now is,
Okay.
if I'm on campus Tuesday, we're going to do labs. We're going to do the series labs. And Thursday would be here on Zoom. We'd start chapter 4 on parallel, and it's got its own set of calculations and all this different. But I'm not sure what day the surgery is going to be for my mom. So there's a chance if I happen not to be on campus Tuesday, then what I would do would be to have a worksheet for you online for chapter 4. And you would read chapter 4 and start working on that worksheet that's got different calculations on there. You would kind of do what you could on it. But I'll let you know tomorrow afternoon when we see the surgeon, and they should be able to give us a day when she have the operation, and then I will kind of know, am I going to miss a day? And probably will. So probably will miss one day, but I'm not sure. If they decide to go ahead and admit her tomorrow, and they were to do that surgery over the weekend, because it's not good. She's only got a real small opening in there. It's supposed to be a large opening, and he says it's very small, way down about the size of a dime, the opening in there, and it's just dangerous. So I wish they'd go ahead and do it quick and get it out of there, but and then I it might not even miss any work, so. But anyway, any way you cut it, we'll one day at a time, and I'll keep y'all posted. And I set up on my phone a text group, and I'll do an email and I'll do a text group, because there's a few people that don't really watch email very well, that they're just.
Well, I see it at the end of the day because I got it connected to my old phone, and I just check it at the end of the day usually.
Yeah. If someone would at least check it once a day, then they would stay on top of things. I just hate for it to be, if I change a plan and say that we're going to do something online for Tuesday, and then people show up and because I didn't check email, so that can happen. So, but I before I started this session, I went through and created a group, a text group with phone numbers, and I've got everybody's updated numbers. So I'll do it like that, kind of redundant, so we can make sure everybody does know what's going on. So okay, so I feel good. I'm happy that y'all have answered the questions what they're supposed to be. These last two, you can answer from our lab that we did in person Tuesday.
Mm-hmm.
Now, Renee, you weren't here, so what we'll do is these last two, you don't need to answer them. You don't submit the worksheet. Go ahead and do everything
Okay.
but the last two, and don't hit submit.
Okay.
And then when I can still go in and look at them. I can still go in and and see what you got, and make sure that you're going. I can still view what you've done. But these last two, Jamie Jones, I had him set a board up with 4 light bulbs in series, and we put 2 different faults in there, and everybody saw with a live board what the results was when we had 2 different kind of faults. And so it's to make it fair on you. You save them answers right there till after you see this in the shop, and then it'll be easy to answer then. But
Okay.
But it's hard. It is really hard to really the picture, really what's going on here until you see it on a real board. So I want things to be fair on y'all. So that's why we did what we did Tuesday, and we saw it on a real board with a meter and all. And then you saw the bulbs, what the bulbs did, and then what the meter was telling you and all that. And when you do that, then it gets it clear for you then. So. Okay, but yeah, do everything you can, but them, and then don't hit submit, and then you can come back in after, and then finish it. So.
All right. Okay.
Well, thank y'all for joining, and y'all have a blessed weekend, and
You too.
let me know if you have.
Good luck with your mom.
Thank you, I appreciate that. Yeah.
I hope your mother gets better.
Thank you. We appreciate everybody's prayer support, and she needs it right now, and that's kind of a tough thing to hear yesterday. He come out there and said what he did, and we just didn't we knew something was bad wrong, but didn't know. But the good news is they can get it out of there. That's the good news. So
That is the good news.
they can go in there, and the nurse said that they'll go out a little bit beyond the bad section. They'll give them some margin in there of good, and then they'll cut that out and then resplice it. So.
Good deal.
This surgeon up there at Rex is a lady surgeon, and that specializes in laparoscopic. They do a small incision, and they can go in there and cut and splice and all that with a small incision. So that's what we're hoping to get done. So, well, thanks, and I'm gonna go ahead and end this thing, and y'all have a nice weekend, and I'll let you know tomorrow afternoon what our plan is for Tuesday. I'll have something for you. If I'm here, it will be here, and if not, then you'll have a Moodle assignment that'll be there for you. So.
Okay. All righty, Durwood.
Yeah, thanks. Have a nice weekend.
Have a good. You too.
Bye-bye. And if anybody is watching that's not connected with our college, again, my name is Durwood King, and my email is dking@sampsoncc.edu. If you want to inquire about taking classes here to get our whole certificate or degree, I can give you information on that. You can also see it on our website, www.sampsoncc.edu, and you can see everything there. The overall program information. And for details, get up with me. Be glad to have y'all register and further your education. And thank you for watching. Have a blessed weekend, everybody.